Hello friends, very good afternoon. Myself Dr. M.H. Annaya, and in today's video we are going to learn about the development of the lateral surface of a square pyramid which is cut by a section plane which is normal to VP. And friends, first of all we should write down initial position of the object. He says in the question that it is resting on HP with an edge of the base parallel to VP. So we will start with the XY line, the line of intersection of VP and HP, mark the top and front views to the given dimensions. Friends, first of all we will draw this XY line, the line of intersection of VP and HP, and here this VP and HP indicates the first angle projection. We have a square pyramid. Dimensions are given. Hence, I am going to construct a square here having dimensions 30 mm by 30 mm. So, this is 30 and all the sides measure 30 mm. And we will just name these corners as A, B, C, D. This is A, B, C, and D. This is the base of the pyramid. If you join the diagonals, they meet at a common point called O, the vertex. So we will project all these lines upward and show the front view of the object, a front view of that pyramid. So friends, this height is given to be 60 mm. So I draw a vertical line through this O, and this gives you O dash. And here friends, you can see this O dash, the vertex, is to be joined to all these corners. That is, this is A dash, B dash, this is C dash, D dash. So I am going to join all these four corners to vertex. So I am going to join O dash to A dash, O dash to B dash, O dash to C dash, and O dash to D dash. So totally there are four slant edges for this square pyramid. So this is how the pyramid looks in the front view. Friends, here you can see, as per the question, with one edge of the base parallel to VP. So this AD is parallel to VP, or BC is parallel to VP. And the same problem can be stated as one of the edges perpendicular to VP, or two edges of the base perpendicular to VP. Friends, it is all the one and the same. That is valid only in case of the square pyramid. So this is O1 dash, O dash, etc. We will mark this O1 here. O1 is the center of the base. So we have placed the object on HP with the one of the base edges parallel to VP. You can say AD is parallel to VP, or BC is parallel to VP. Then he says it is cut by a section plane which is normal to VP. Friends, whenever the section plane is normal to VP, it is seen as a line in the front view. It could be a horizontal section plane, it is normal to VP, an inclined section plane, that is normal to VP. So whenever the section plane is normal to VP or perpendicular to VP, it is seen as a line in the front view. So let us see where it is located. Normal to VP and inclined at 40 degrees to HP at a distance of 25 mm from the vertex. So friends, I will take a point here on the axis O dash, O1 dash at a distance of 25 millimeter from the vertex O dash. So the section plane should pass through this point at an angle of 45 degree. So friends, I am going to mark the line, the section plane SS passing through this axis at a distance of 25 millimeter, and the inclination of the section plane with the HP is given to be 40 degrees. So this angle is 40 degree. So you have placed the object and you have shown the section plane SS which is normal to VP, and cutting the solid at a distance of 25 mm from the vertex. Friends, now let us see which is the portion that is retained. Friends, the portion below this section plane is retained. That is to say, this is the portion that is left over. Because in the question, it is mentioned, draw the development of the lateral surface of the lower part of the pyramid. So this is the lower part. I will call it as part P. And this, for this part, we have to draw the development. So after this is being cut, we throw away, we assume this to be thrown out, and we want the development for this lower half. Now friends, we know the section plane is cutting at an angle of 40 degree, and let us draw the development of the lateral surface, assuming it is not cut by any section plane. So we will just draw the development assuming it is not cut by any section plane. And you know friends, for all these developments of any object, a cone, a pyramid, a cube or a prism, we need to have the actual dimension, whether it is a slant edge or a longer edge or a base edge. Friends, you can observe in the front view, O dash, C dash, O dash, D dash. They are the two slant edges where the section plane is cutting. And here also got O dash, A dash, O dash, B dash. But if you see the top view, none of the top view of these slant edges is parallel to VP. That is to say, none of these four vertical edges, OA to OD, represent the true length. So what is to be done in that case? Friends, we have to make one such parallel to VP. So I just draw a horizontal line through here, a horizontal line. Taking O as center, OD as radius, I strike an arc. It will meet this here. So I will write a vertical line from there and join that to this O dash. So friends, this line, whatever I have drawn here now, will represent the true length TL. So this is C dash D dash, will keep as it is. So this length will give you the true length. TL is the true length of the slant edge. So true length will be same for all. So it is one such. So friends, now I know the true length. I am going to take this point as O and draw that length TL here. See, I have made this figure a little bigger so that you can see the salient points in that. And here this side is 30 mm. From this point I am going to make 4 arcs, 30 mm each. So this is 30, 30, 30, 30. And join all these by thin line. So we are going to join all this by thin line. I have made 4 lines here, 4 base edges, because the square pyramid has got 4 base edges. And let me also join all this by thin line to start with. This is 1, second, third, and then this is 4. Friends, now next comes the marking of the slant edge in the development. Friends, here you can observe, after the section plane cuts the solid, we throw away this upper part, and you see smaller portion of OA, OB, OC, OD, that is smaller portion of the slant edges of the pyramid are remaining or left over. And hence what is to be done, friends? Now here we can start the development from OA or OB or OC or OD. The choice is ours, because none of these slant edges are removed after the section plane cuts the pyramid. So friends, I can start from this A itself. So I'll mark it as A, this is B, C, D, and again A, because starting and end point should be same. So friends, if you observe here, the solid is cut by the section plane at this point. Which are these? These are on OA, OB. So OA and OB are here. Friends, I have to get these 2 points on OA and OB, because the length OA dash, O dash, B dash is not the true length. So what I do, I draw a horizontal line from there till it meets the true length point, true length line point. and mark this distance on OA and OB in the development. So I am going to mark OA, OB and OA in the development. Next friends, you can see these slant edges O dash C dash and O dash D dash are cut here, but this is also not the true length. Hence I shift that point to the true length line here and mark the distance on OC and OD. So on OC and OD I get the same distance. So friends, here you have got 4 points. Let me mark them as 1, this is 2, this point is 3, this is 1, 2, 3, this point is 4, and on OA it is again 1, 1, 2, 3, 4, 1. And then friends, if you observe the base of the pyramid, that is all the 4 edges of the base, namely AB, BC, CD and DA are not stretched by the section plane, and hence we have to show all those lines by visible lines, dark lines. So I am going to join like this: A to B, B to C, C to D, D to A, all by dark lines. And here all these points to be joined by straight lines: 1 to 2, 2 to 3, 3 to 4, a full line again here, 4 to 1. And friends, here the portion below the section planes which is retained, that is, if I am just transferring these points, this is 1 and 2 here, this is 1 comma 2, this is 3 comma 4 here, so to take it as 3 comma 4, so 3 comma 4 is here. So friends, this slanted edges are cut here. The portion from 1 to A, 2 to B is retained. 1 to A is to be shown by a full line, 1 to A by a full line, then 2 to B is also retained, 2 to B I show it by a dark line. I have marked this. Then you have got points from this, that is 3 and 4 are here. This part is also retained. So I have to show these two also by dark lines. Friends, if you observe this figure, here this is 1 to 2 is parallel to this, and this line 3 to 4 is parallel to this, and on OA and OB you will have same measurement retained. Friends, this portion shown in color, that is 1, 2, 3, 4, 1, A till this A and 1 will give the development of P. I will say DEV, development of P. That is the development of the lateral surface of the lower part. This is the lower part of the square pyramid. Friends, I hope the presentation was interesting, and if you like this video, do share with all your friends without fail, and have a wonderful day. I thank you very much for watching my YouTube video.